Hi everyone, today we'll be starting Unit 5. Unit 5 is going to be all about systems of equations and inequalities. As we work through this unit over the next 3 days, we're going to learn about 3 different methods that we can use to solve those systems of equations. Today we're going to start with graphing. Alright, so before we do that, let's just review graphing an equation. So, do you remember how to graph a line on a coordinate plane? So here is an equation that we have. I want you to go through and on your own answer those 5 quick little spots. Okay, that's your quick warm-up, and we'll check those in class. So go ahead, pause the video now. Okay, now let's come down here and see what happens when we do actually solve these. Okay, so, or not solve them, graph it. So remember how to graph a line that's not in slope-intercept form. So we're going to go ahead and graph it on the coordinate plane above. Now this equation here is in standard form. My x and y are together on the left side and then the constant on the right side. So one method that we learned was to just graph our intercepts. To do that, to get our x-intercept, we could cover up the y, and then we would divide by 8. The problem is we can't do 12 divided by 8 and get a whole number. So intercepts are not going to work in this case. So what we need to do instead is follow these 2 steps to get this equation into slope-intercept form. First, we're going to move the x term using addition or subtraction. So I want to take my x term and I want to move it over here with the constant. I'm trying to solve for y. So I'm going to subtract 8x from both sides. And when I do that, I end up canceling out those 2 8's, or the 2 8x's. And we're now left with 4y equals negative 8x plus 12. I like putting that x term first because the slope-intercept form is y equals mx plus b. Alright, so now we need to isolate the y, so we're going to divide all the terms by the coefficient of y. So divide by 4. And when we do that, cancels those out, and now we can go through and do our division. And we are left with the equation y equals negative 2x plus 3. Now we have the equation in slope-intercept form, so we can identify our slope, which is negative 2, and our y-intercept, which is 3. Alright, so in order to graph this, we start with our y-intercept, which is 3. So we'll go to the y-axis and put a point at 3. To do the slope, we really need to do that as a fraction, because remember, it's rise over run. So I'm going to turn negative 2 into a fraction by putting a 1 under it. Alright, so let's go ahead and graph it. So my y-intercept was 3, so I'm going to come here and put a point at 3. Now I can graph the slope of negative 2 over 1. So I'm going to go down 2 over 1, down 2 over 1. And I'm going to keep following that pattern until I've run out of room. And then I can check to see. I can do the opposite and go up to left 1. And I can see if there's any other points I can put on my line. Up to left 1. Once I have all my points, then I can go ahead and draw my line through, and now I've graphed it. Okay, so that's your review of how to graph a line. Now let's go over here, and we're going to utilize that skill to help us solve a system of equations. Alright, so what is a system of equations? Well, it's 2 or more equations that are on the same plane. So if we were to graph them, you would have 2 or more lines that are on that same plane. A solution to the system is the point where all of the equations intersect. It's that ordered pair. So when we have a system of equations, they're all going to have the exact same x and y value, which shows where they cross, where they intersect. Alright, so let's go ahead, and we've got 4 problems. We're going to do 2 together, and you're going to try 2 on your own. Alright, so first, This first one, they're both in slope-intercept form, so that makes it a lot easier for us. All right, so we're going to come here and we're going to identify our slope and our y-intercept. So our slope is 2, our y-intercept is -4. So let's go ahead and get that graphed. So I'm going to start with my y-intercept of -4, and then I have a slope of 2. Remember, I need that really to be a fraction, so it's really saying 2 over 1. So I'm going to go up 2 over 1. I'm going to fill in all my points. And then I'm going to put my line in. So that's y equals 2x minus 4. Now let's take care of the bottom one. Y equals -3x plus 1. So I'm going to identify my slope is -3, my y-intercept is 1. I always start with the y-intercept, so I'm going to put a point there. Now my slope is -3 over 1. So down 3 over 1. Down 3 over 1. I already have a point there. So down 3 over 1. I'm going to see if I can get any more. So I'm going to go back to the start and do the opposite. Up 3 and left 1. Now I can graph my line. And we can see that they intersect right here. So that point right there is our solution. So we say that our solution is the ordered pair for that point, 1, -2. All right, I want you to come down here to number 2, and I want you to try this one on your own. So this one here, try on your own. Go ahead and pause your computer or your video now. Okay, hopefully you're able to get those two graphed. We'll check those in class next time. All right, number 3. So this time we want to graph, but again, we have equations that are not in slope-intercept form. So we need to get them there. All right, in order to do that, I've got to isolate y. So these are actually pretty nice because y does not have any coefficients for both equations. So all I have to do is take this x term and move it over to here. So when I do that, I'm going to add 1/2 x to this side. So now I get y equals 1/2 x minus 1. So I brought the -1/2 x over by adding it, and then I've got this minus 1 that just goes to the end. All right, and then I can change this one. So again, to isolate y, I'm going to add the x over to this side with the -3. And we end up with y equals x minus 3. All right, so let's get to work graphing. Now that we've got those done, okay, I'm going to start with the first one. My y-intercept is -1. My y-intercept is -1. My slope is 1/2. That means I'm going to rise 1, run 2. Up 1, over 2. Up 1, over 2. I've run out of room. I'd like to get this half of my line. So down 1, left 2, down 1, left 2. And then I can draw on my line. So now I've graphed y equals 1/2 x minus 1. All right, now let's graph this one here. This one has a y-intercept of -3. And it has a +1 slope. If there's no number there, it's 1. So put that over 1 to make it a fraction, and we have a slope of 1 over 1. Rise 1, run 1. And I'm going to keep doing that till I get all my points that I need. I've already got a point there, so I can skip that one and come up to here. I can finish filling these in, going in the opposite direction, and now I can draw my line through. So our solution is where they intersect. So they intersect right here at this point. So we would say our solution is 4, 1. Now I'd like you to come down here and do number 4 by yourself. You are going to have to put both of these equations into slope-intercept form. Be careful because the coefficient of y is a -1, and this one has a coefficient of 3, so you're going to have to divide as well. Right, go ahead, pause your video now. Or before you do that, once you've finished, I want you to answer this question here. All right, so now go ahead and pause your video now. Okay, let's go to the next page. All right, sometimes you're asked to verify a solution in a system. So to do that, so here we have a system of equations. We need to figure out which one of these ordered pairs is a solution to that system. So to do that, we're going to just take them and one at a time work through each ordered pair. So we're going to start with that 6, -14. And we're going to take those two values and we're going to substitute them into both equations. In order for it to be a solution, that ordered pair must work in both equations. All right, so let's go ahead and plug this in. So this is my x value, this is my y value. So I'm going to substitute x with 6 and y with -14. All right, now all I need to do is simplify this side. If you've got a calculator, you can just put the whole math problem into your calculator, or we can do it step by step. 2 times 6 is 12, and then 5 times -14 gives me a -70. So now I'm down to 12 minus 70 is supposed to equal 8. I just carried that down. All right, now let's do this math. 12 minus 70 gives me -58. It's supposed to equal 8, but we can clearly see that it does not. So we are going to put a slash through that equal sign, because -58 does not equal 8. Okay? So this ordered pair does not work in this equation. But let's just check it in this one just to see what happens. 6 and -14, I'm going to substitute in for x and y. I'm going to take care of the math. So -6 times 6 is 36. 4 times -14 is -56. When I subtract them, it's supposed to equal -20. Let's see if it does. When I put that in my calculator, I get -20 equals what it's supposed to, -20. So this ordered pair works for this equation, but it does not work for this equation. Remember I said in order for it to be a solution, it has to work for both. So 6, -14 is not a solution. All right, let's check out B. Okay. So this time they're saying we're going to use an x value of 14 and an x value of -4. I'm going to substitute in my two values. I'm using the exact same equations, right, because we're going to test out all 4 ordered pairs to see which one works for both equations. I'm going to do my math. 12 times 14, it gives me 28, and then 5 times -4 will give me a -20. 28 minus 20 should equal 8. So let's check, and it does. So 8 does equal 8. Okay? So in this case, 4, -14 does work in this equation. Okay? Now we need to come over and check it in this one. I'm going to use the same two numbers, 14 and -4, and this time I'm going to plug them into the second equation. I'm going to take care of the math. So 6 times 14 is 84. 4 times -4 is -16. I'm going to take care of the math. 84 minus 16 gives me 68. 68 does not equal -20. So I'm going to put a slash through that equal sign to show that they're not equal. So that ordered pair does not work for this equation. So since the ordered pair does not work for both of them, it cannot be a solution. All right, I want you to come down here, and I want you to do the next two on your own. All right, so C and D are trying your own problems. It's not written out for you, so you're going to have to take what we did here, bring it down. So write the two equations, do your substitution, and then you're checking to see, does this ordered pair work in both equations? If it does, it's a solution. If it does not, it's not a solution. Go ahead and pause the video now. Okay. Last page. So we're going to do this essentially in class next time because this one requires the calculator. But one of the things I do want to show you is that we can also do this in Desmos. So I'm going to show you here how to do this in Desmos, and then when we get to class next time, I'm going to show you how to do it on the graphing calculator. For any unit tests or quizzes that we do in class, you're only going to have access to the graphing calculator. For the SOL test, you will have access to both Desmos and the graphing calculator. All right, so I'm going to go ahead and open up my browser. And I'm going to get that graphing calculator going. It used to be the very first one. It's no longer showing up where I need it to. All right, so I'm going to come here. You guys should have that link already on your screen. I really wanted the graphing one, or the test one. Let's see. Sorry about this, guys. It's just not going to where I want it to go. Alright. This will have to do. It's not the Virginia one, but it is. It's not taking me to the graphing one. Why? Okay, I have the calculator up and running now. So now, I'm going to pull this over here to the side, and we're going to take a look at this. So mine's kind of small, but you can look at your paper. We've got these two equations here. I can come over here to Desmos, and I can type them both in. So y equals negative 2x plus 2. And it graphs the line for me. Now I can come down to the next line, and I can graph the other equation. Y equals 2x minus 2. So now I'm looking for where they intersect. So I've got this red line, I've got this blue line, and they intersect right here at this point. My ordered pair, my solution is that 1, 0. So I can type that in here. So the solution we were able to find through Desmos just by doing that. Okay. Now when we come into class, we'll take a look at how we do that in the actual graphing calculator, following these steps here. Okay. Now, sometimes we get something different. We can have, all the ones that we've looked at so far have all had one solution. Okay. They intersect one time, and that's it. Sometimes you'll get two different equations that form the exact same line. Okay? So while it looks like there's only one line there, there's actually two, it's just one is over the top of the other. When that happens, we say we have infinitely many solutions. And then sometimes we'll get two equations that give me two lines that are parallel. When that happens, we say that there are no solutions. Okay, so the two lines never cross is no solutions. Two lines on top of each other is infinitely many solutions. Two lines that cross at one point is exactly one solution. All right, so we're going to come down here, and I'm going to show you the nice thing about Desmos that we cannot do in the graphing calculator. So I'm going to clear these two out just by hitting those X's. The great thing about Desmos is it doesn't matter what form that equation is in. I can just type it in. Okay? The graphing calculator, we have to convert them over to slope-intercept form. All right, so negative x plus y equals 2. There's that equation in green. Now I'm going to graph the second one. 3y minus 3x, oh, not minus, sorry, equals 3x plus 6. And now it graphed, and what you're going to notice is now it turned it blue. So I started with a green line, and then it ended up blue. Those two lines are right on top of each other. So we say that this one has infinitely many solutions. And then we're going to come back and we're going to take a look at that next class and see how we do it in the graphing calculator. All right, let's just take a look at this one here. So again, in Desmos, I can type in an equation in any form. This is going to be really nice when you go to take that SOL. Okay, so I typed in the first one. Now I can type in the second one. And now we can see that these two lines run parallel to each other. So they never cross. So in this case, we would say that this one, oops, where'd it go? This one here has no solutions. So again, next class, we're going to look at how to put these all into the graphing calculator, but I did just want to show it to you on Desmos so that you have that option to check your work when you're at home. Okay? And since you have that, you can now use that to go ahead and work on these two try-on-your-owns here, or at least check your answers. Okay? All right, that is the end of our video. Please make sure you've completed all your try-on-your-owns, and I will see you in class next time.